Hello. So today I'm going to be attempting to do another live solve here. This is an aptly named Little Killer Sudoku by Nityant Agarwal. And I don't think I've done any pure little killers on this channel before. And you might find out why when I attempt this. I am not the best at little killers, but he specifically asked me himself if I could solve this on the channel. And who am I to say no? He even said if I fail the attempt, he wants to see the failed attempt video. So either everyone's seeing this or just Nityant, you're seeing this. But either way, I hope you enjoy it. Now, another thing I'm going to point out is I'm going to try my hardest to point at it. Yeah, it's like mirrored. Okay, so anyway, right above the puzzle next to the 34, to the left of 34, there's a black box with a 0 in it right now. That is going to be displaying my calculator throughout this. I am not above using a calculator. I think adding in your head is definitely a useful thing to do, but I think I've experienced in past videos that if I fail to add correctly, it just wastes a bunch of time. So I am going to be using the calculator. So don't feel bad if you also use calculators for these things, just to make sure I don't make any dumb addition mistakes or subtraction mistakes, that sort of thing. And so I have that in clear view so you can see exactly what I'm adding and when I'm using it. The rules of this puzzle are just standard little killer rules, which is actually pretty amazing considering that there's no givens at all in this puzzle. So I'm hoping to find some useful clues to start out with. But the rules are, we have these arrows with a number next to them, like this 9 with an arrow, this 13 with an arrow. And they point up a diagonal. So like this 9 points up this diagonal, this 27 points up this diagonal, etc. They go in that direction. And all it means is that if you add up all of the cells along that diagonal, all the way to the other end of the board, it equals that number. Digits are allowed to repeat. There's no restrictions on that. So we just have normal Sudoku rules about whether digits can repeat. But the restriction is that the cells along those diagonals must sum to that value. So those are all the rules. And I'm a little bit daunted considering my inexperience with little killers, but we will try to solve this together, I suppose. And with that, you can check below. I have to point below when I say below. It's a YouTube rule. But you can check below for the link to the puzzle to try it yourself. All right, so I will get started. And I think the very first thing to look for is arrows that are somewhat restricted in what they can be, like low values or high values for the number of cells they hit. And I am seeing quite a few like that potentially. Like this 6 is going to be either 1, 5, 2, 4, and it can't be 3, 3. So that's somewhat restricted. Let's just go around 14 and 3. So 1 plus 2 plus 3 is 6. So I think 14 is somewhat middling. So I'm not going to look at that quite yet. This 15 and how many is this? 1, 2, 3, 4, 5. 15 and 5 averages 3. So what would be our minimum? Our absolute minimum is 1, 2 across this diagonal, a 1 here, and then 1, 2 across this diagonal. So that would give us, I don't need a calculator for this, 13. So we get 2 degrees of freedom. So what that means is whatever the minimum value is for any of these cells, we can be up to 2 higher. So for example, if I choose to use 4 for this cell here that's highlighted, then I would be doing 4 plus 2 is 6, plus 1 is 7, plus another 3. Maybe I did need a calculator. I am very sorry for already being completely dumb. I don't know why I thought I was thinking 1 plus 2 plus 3 as I was writing these. So forget what I said. This is actually still pretty small. This is 7. Okay, so even this 15's not really. Is there, like, can I have a 9? Well, 7, I don't think I can have a 9. I think I can have an 8 though. So 8 plus 1 is 9, plus another 1 is, no, I'm wrong about that. I can have a 9. We can have these three can add to 4, so I could have 11 here. Never mind. All right. 9 and 3 is still has a lot of options. Obviously, we can't have a 9 here. 10 and 2 can be anything. 9 and 3 again. Okay, well, the other thing to look at with little killers, which I suspect given the pattern of these, is you actually look at several of them together as a group. So I don't really know which one to start with. Maybe this one, because it does seem pretty small. So let me just highlight these cells here. Maybe I'll use blue. Easier on the eyes, maybe. All right, so all of these blue cells will add to whatever the sum of these are. Hopefully that's fairly obvious to see. So that's going to be 15 plus 15 plus 9 plus 16. So that's 55. So all of these cells add to 55. Now what we also know is that this box adds to 45 because it has all the digits from 1 to 9. So let me mark that orange. So one relationship we could give, which I don't know if is super useful, but we could say that the blue cells minus 45 is equal to these cells. Okay, well maybe I'll mark these as a different color, like purple. So how do I want to put this? Well, what we know is that the sum of all three colors is 55. So 55 minus these blue cells is going to be the purple cells plus the orange cell. That doesn't seem... Okay, so maybe we need to... Why don't I just highlight every cell that's affected by the little killers at all and see if anything pops out there. Now there is going to be overlap, which makes this a lot more difficult to wrap your head around. Let me just color those and continue. So we've got... maybe we'll see what happens if I highlight where they overlap as well. We get this, did I do this right? There's also kind of this diamond pattern. So there's a few things happening here. I feel like I missed something here. Like, is there some... Oh, I see. It's not quite symmetric. Is it? It should be. It just doesn't look... Like, shouldn't this cell be... Sorry, I'm getting a little bit confused as to why it doesn't look symmetric to me. But maybe I'm just not thinking about how these shapes work properly. Forgive my double checking here. I mean, this all seems to track, so... Yeah, it's the top and the bottom. Yes, we have 5 numbers on the bottom and 4 numbers on the top. Oh boy, this is probably not going to be a great solve if I'm missing 5 versus 4. But anyway, that explains it. It's a bit lopsided. So the obvious things that stand out is, you know, these 4 corners here. So we have, so first of all, we don't touch the center box at all. So that's interesting. Secondly, we almost have the other 8 boxes. accounted for, almost. And obviously we know the 8 boxes add to 405. So let me highlight the cells that are, so these are the cells in orange that are included in the 405, but not in the little killer sums. Oh, I missed these as well. But we also have overlapping cells. So let's figure out where those overlaps happen. Which ones are counted twice, basically? This one's counted twice, and I'll make that purple. Is it just that one? Yeah, that one's not counted twice, none of these. Okay, so how about here? This one's counted twice. None of these are. This one's counted twice, as well as this one. Is this one? This one must be, right? Why is this one blue? Oh, because of the 28. But it doesn't actually get counted up here, so that's fine. This one's counted twice, okay. And then up here, so we have this one counted twice. We have this one counted twice, which just making sure I didn't miss any. So I think that's it. And then what do all these add to, I guess, is the next question. 34 plus 30 plus 14 plus 6 plus 15 plus 15 plus 9 plus 16 plus 28 plus 40 plus 24 plus 9 plus 10 plus 13, 27, 13, 9. So that's 312. So what we're saying is 405 minus the orange minus the purple, because they were counted twice, is 312. And that means nothing to me. Well, 405 minus, I messed that up. Let's just clear that. 405 minus 312 is 93. So how many cells is that? That's 4, 5, 6, 11, 12, 17, 18, 21. It's a very middling number. Why didn't I color those orange? So it's 95. Wait, what did I say? No, 93 is still the correct number, but there's not 21, there's 23, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So yeah, there's 23, but that's not going to make a big difference on the 93 sum. That's almost exactly 4. 4.5 would be the average if they were random. Is there anything interesting with the rows, or? Not that I'm seeing. How do you do this? Well, if it's not all of them together, we could look at, we looked at this block Didn't really see much with that. I haven't looked at this one. Has 5. Maybe it's special. All right. Well, let's just clear all this out. Start over. So let's highlight all this. There. Is this any more interesting? Well, what do they add to? 28 plus 40 plus 24 plus 9 plus 10 is 111. And then 3 boxes of 45 is 135, right? Let's just double check. Yeah. So that means that these 7 cells add to 24, which is an average of 3.4. These are minimum 6 each. So that would be 12. So this could be 9 and still be fine. $40 and 5. That's potentially interesting. What's our so we can be 9, 8 here, which is 17. So 2 lots of 17 plus 1. Let's just do that. So 35. So we actually, so if we put 8 9s in here, I'm just going to get rid of this highlighting. We have 5 more degrees of freedom. That doesn't seem so great. So just to double check, that means I could put a 4 in here, right? So 17 plus 17 plus 4. No, I couldn't. Five degrees of freedom for the maximum, I thought. So the minimum I can put here is 6 then. Oh, okay. I don't know what I did. I did plus 1. I don't know why I did that. So 17 plus 17 plus 9 is 43. So we get 3 degrees of freedom. So that's 3 down from the 9. So here we could be as high as 5, or as low as 5 on each of these. That's still really unhelpful. And I might as well put this 6 back in. I really do think there's going to be a geometric thing going on here, but 24 and 4 averages 6. This pattern's the same for all of the ones with 4 on the side. So this is 111, the bottom. The right was 55. So what are these other ones? The left side is 62. The top is 84. So let's highlight the top then. All these are in orange. So we could potentially do 135 minus 84 is 51. So the oranges here have to add to 51. That's interesting. So I'm pretty sure 1 through 6 adds to 21. That just still allows a 9 in the other orange. So we still have full degrees of freedom on it. What is 84 minus 44? It's 40. So if this were a 1, then these 6 have to add to 40, which is still possible. Okay, so what if there's something like, how would I even do this? Maybe that's not the best. Well, 22 minutes and I have no idea how to even start this puzzle. Is it really true that this 13 isn't limited? Okay. Well, this is minimum 5, so this can be 1. What mood am I in? This can be 1, this can be 1, and these can be 1, 2. So that's 6, 7, 8. Sorry, I did 6 again. What am I doing? 3, 4, 5. 10 minimum. Yeah. So actually, does that mean we can't have a 9 on this one? Yeah, so we just can't have a 9. Because 8 plus 7 is 13. No, it's not. But that's also not 7. 8 plus 5 is 13. So if this were a 5, how big could I make these, right? So I can have these add to 8. And they add to 5 right now. So that gives me 3 more degrees of freedom. And then the 5's here. So just to double check, I can do 5 plus 1 plus 1 plus 1 plus 5. That gives 13. Okay. So then does that affect this 34? These would have to be large, right? So that's 17 plus 9 plus 9 is already 35. So that's not limited at all. I don't know. Is this a red herring, or is there something I can do with this? Like, does that limit this 13 at all, or this 9? Not really. So this entire set Is there something like that I can do with how, like what this overlap could be because of the total sum and the repeat? The thing, okay, well, 28 in 6 averages 4.5. That's all these middling values. 27 over 4, it's a little bit higher. So if I do 28 plus 27, and I need to do that in 4, 5, 6, 7, 8, 9 cells, that averages 6. So these are going to have to be a little bit lower, and these a little. What does that mean? And we have the overlap. It's 55 with the overlap, right? Still don't know what that means. Oh, 16 and 2 is 9 and 7. Does that do anything? Nine and 3. Max is at 7, but we can't actually use a 7, so these are going to max at 6. It'd be 6, 1, 2, or 5, 1, 3, 4, 2, 3. 15 and 4. I think we did this one already. So we said we did this 15. Okay, well this one is minimum 5 as well for this 15. So that's got to affect things, right? So these can be 3, 4, 5, and then another 5 at least. So at maximum, we have another 5 degrees of freedom. So if this were 6, we'd have 5 plus 6. 5 plus 6 is 11. 12, 15. Okay. And these go to 7. We checked this 34 already. Well, how about this 15 here? So the interaction of these must do something, but I mean, there's nothing to do with these. What's our maximum? Like, can I have a 9? Yes. Because I can do 9, 1, 2, then the rest. Can I put an 8 in one of these? Seems like I should be able to. So let's say that one were 8. I'd have remaining 7. I can do 7 in a bunch of different ways. The reason I asked is we don't have an 8 placed in this box yet. So we know 8's in one of these 3. Okay, 14 and 3. Does that cap out at anything? No. Okay, well, the maximum for, I'm in corner mode. Maximum for the 30 is 18 plus 17, which is 35. So does that mean I can have a 4? Well, yeah. I really don't think this is the right way to do this, but grasping at straws here. 34 in 5. The largest we can be is 5999, right? And then a 7. So 27 plus 7 plus 5 is 39. So that's actually another 5 degrees of freedom. So just to double check, this one can be 4. So 5 plus 4 plus 9 plus 9 plus 7 is 34. So this can be 4. This doesn't feel like the way to solve this puzzle. The 10 can't have a 9. The 9 can't have a 9. So the 9's in one of these. Can we have a 9 here? I'm pretty sure we can. Don't see why we couldn't for 24 and 4. Easy. So something like that. The 14 can have a 9. Can the 14 have a 1? Yes. Don't see why not. I'm just trying to figure out if there's a value that must go into a corner in one of these boxes. It is really suspicious about 8s in this box, but that could just be something coincidental. So these guys can't have 8 or can't have 9. They can have 8 though. So no 9s here. Can have a 9 here though. Is there some geometric property that I'm missing about this that'll crack it open? Maybe with fresh pencil marks, there'll be something that pops out here. I don't remember what this totaled to, but we only had a few overlaps, if I recall. There was this one here that overlapped, this one here, 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 and these two. I think that's right. Okay. And then these are not part of the sums, but are part of the boxes. Missed one again. Okay. So we take the sum of the boxes, we subtract the oranges, and we add the purples, and that gives us the sum of all of our little killers. And that really still means nothing to me. Do I stare at this more? I know Simon's done several puzzles like this where he's managed to glean something, but I am not seeing what to do. Four or five minus the orange plus the purple. So let's just add all our little killers again. 15, 15, 9, 16, 28, 40, 24, 9, 10, 13, 27, 13, 9. 312. Is that the same number I got last time? 34, 30, 14, 6, 15, 15, 9, 16, 28, 40, 24, 9, 10, 13, 27, 13, 9 is 312. So 405 minus the orange plus the purple is 312. So 405 minus 312 is 93. So 405 minus orange plus purple is 93. So 93 is purple minus orange. Did I say that wrong? We have a lot more oranges than purples. Let me just do that one more time. So 405 is the sum of these 8 boxes. If I subtract the oranges and add the purples so that the purples double count, then I get my little killer sum of 312. So if I subtract 312, that's 93. So 93 minus the oranges plus the purples is 0. So 93 plus the purples is the oranges. So 93 is orange minus purple, which makes a lot more sense. So the oranges are 93 higher than the purples. What is the minimum value of our purples? Oh, is that even what I want? What am I thinking about? 93 does seem pretty small. Well, okay, so what can the oranges add up to? Let me just... So it's going to be 10, 20, I mean minimum. They must add to 10, 20, 13, 16, and then another 4. So 30. Okay, well, maximum, what do they add to? So 9 times 4. Oh, wait, but this corner can only be 8. So let's do this right. 9 times 3 plus 8. These guys can be 17. So can these? These can be 9876. And so can these. So 129 is our absolute maximum. And what's the absolute minimum for the purples? We need to make 93. So we need the purples to be 36 or lower? Higher. Orange at maximum is 129. So in order to subtract the purples and get 93, the purples have to be at least 36. At most 36? Yeah, because if we were 92, we would want to subtract 35. Or sorry, if we were at 128, because we can't go to 130. 129 is our maximum. So if we were at 128, we'd want our purples to be 35. So our purples need to be 36 or lower. So what's the minimum for our purples? This can be 6. Oops, 6 plus 1 plus 1 plus, these can be 3 and another 5 is 8, 16. Great. So that gives us a minimum value for the oranges then. There's some relationship there. So purples can at minimum add to 16. I really feel like this is not going anywhere, but let's just keep this train of thought. So purples at minimum add to 16. Is that right? We got 6 plus 1 plus 1 plus 8. Yes. So 93 plus 16. Purples are between 109 and 129. So there's a 20 degrees of freedom there. I need to remove more degrees of freedom from the oranges and the purples. I wonder if there's something about the oranges that I don't get. Like, okay, so if the oranges were 6, 7, 8, 9 here, what does that do? That would look like that. And if these were 6, 7, 8, 9, then that would look like that. So there's definitely an effect on our purples here. are these sums still possible? Like, can we still get 34 this way? So we can have 3 plus 5 plus 9 plus 5 plus 3. We can't even get close to 34. Okay. So how... Because we have only a certain number of degrees of freedom that we can give on this 34. So if one of these were 6, 7, 8, 9, I don't know how I'm going to prove like the viability of this, but that has a huge effect. 6, 7, 8, 9 specifically has a huge effect on this purple. I don't know if 5, 7, 8, 9 would have the same effect, but let's play with this. So that makes this 1, 2, 3. So we could be 3 plus 5 plus 9 plus 9 plus 7 is 33. So this can't be 6, 7, 8, 9. I'm pretty sure it's the same of the other side as well. But we can just try that. That removes 6, 7, 8, 9 from these, making a 4, 5 pair, which means that causes the same effect here. So 3 plus 5 plus 9 plus 9 plus 5 is 31. Yeah, so our oranges are smaller than we expect because we can't do 6, 7, 8, 9 on these quadruples. So what can we do? What if I just included... I don't know how to think about this. Pretty sure it's fine to just use a 9 somewhere here, right? Because that just removes 9. And then this is going to be way over. Wait a minute. Five plus 9 plus 9 plus 9 plus 7 is 39, yeah. I think I just did that, I did that sum wrong last time. I don't think that means this can go all the way down to 1. No, it can't. As good as that does me. It seems like it can be 2 though. So yeah, there's 5 degrees of freedom on all of these. I don't know how to think about how small these quadruples have to be. Like, what if I was just... Do we have to be really careful about what we do? Like, what about 1, 2, 3, 9? That makes another 4, 5 pair here. Whoops. That still works. So I can't get rid of 5 of the degrees of freedom. I can get rid of 5, but I can't get rid of 6 degrees of freedom from these. And similarly here, this is also going to remove degrees of freedom unless it's low. Between these two, I can only remove 5 degrees of freedom. So I think 5, 6, 8, 9. Am I right about that? Let's try it. We were 5, 6, 8, 9. That removes 5, 6, 8, 9, 5, 6, 8, 9. See, that makes a pair which removed another degree of freedom that I didn't expect. So I think even this isn't going to work, but let's try it. 5, 6, 5, 6, 8, 9, 5, 6, 8, 9. But this 9 didn't remove a degree of freedom. Oh, it removed it from here. This is 4, 7. That definitely, yeah, this is definitely not going to work now. So I wish there must be something about this that I'm not getting that would be easier to represent in some way, but maybe I'll get there. 3 plus 7 plus 9 plus 7 plus 4. That's way too low. So can't be 5, 6, 8, 9. How about 4, 5, 8, 9? Makes a 6, 7 pair. Even that without anything in here is killing the sum, because that's 33. So I think the key is if I use what happened here exactly? Well, something like 4, 5, 7, 9. I'm sorry about this. I can't. There's something here. Something here. So what does this add to? 3 plus 8 plus 9 plus 9 plus 7. It's 36. So that's fine. Oh, this 33 I added whoops. Let's go back to 4, 5, 8, 9. Because I think I added 8s instead of 9s somewhere. So this is what that would look like. And so I could be 3 plus 7 plus 9 plus 9 plus 7, and that's 35. So that's fine. So this can be 4, 5, 8, 9, but then this couldn't use a 7 or a 9. Is that right? I think that's, so if I use 4, 5, 6, 8, that removes 5, 6, 5, 6, 8, 5, 6, 8, 5, 6 from here. Then I can still be 7, 9, 9. Maybe that's just in, okay, so 4, 5, 8, 9, let's just add that then. So that's 26 plus 4 plus 5 plus 6 plus 8 is 49. And then we'll say these oranges can be 17 each. Oops. 15 plus 17. And then we can have 3 9s and an 8. $118. Did I even scratch much off of this? Is there a problem with having 8, 9 on these? Is 40 not possible anymore? It's just possible with 8, 9. Oh, but then if I put 8, 9 here, then we, oof, there's no way. we have to have our full degrees of freedom there. So I'd have to use 6, 7 here. So that I don't get rid of the top possibility. So this would have to be, so it would have to be 4, 5, 8, 9. This would be 4, 5, 6, 8. And then this, I don't think there's a problem. Well, clearly these can't be 2 9s. So this would be 9, 8, 8, 9, like that. So let's add this. Maybe we have to be very exact about this. So the 2 quads are 4 plus 5 plus 8 plus 9 plus 4 plus 5 plus 6 plus 8. The 2 pairs are 6 and 7 and 8 and 9. And then we have 17 twice, 113. So 113 minus the purples is a number I don't remember, and that's very unfortunate. 113 minus the purples. Yeah, it was 80 something, 83 or something like that. I mean, it's still. Okay, I need notes or something. Okay, I have a notepad on another monitor, which I'm looking at right now. So orange max is 113. Let's just add all the little killers again. 34 plus 30 plus 14 plus 6 plus 15 plus 15 plus 9 plus 16 plus 28 plus 40 plus 24 plus 9 plus 10 plus 13 plus 27. 13, 9, 312. 312 sounds familiar. So the little killers must total to 312. And then obviously we have 405 for our 8 boxes. So 405 minus 312 is 93. Okay, so we were saying that the killers, we have 405 minus orange plus purple equals the killer sum, which is 312. So 93 is orange minus purple. That sounds familiar. So if orange is 113, then orange is less than or equal to 113. So $93 plus the purples is equal to orange, which is less than or equal to 113. So purple is less than or equal to 113 minus 93 is 20. The purples can't add to more than 20, is that right? Yes, because then the oranges would not be able to get large enough to actually subtract. That's assuming my quads are right here, but let's just keep that assumption, that there's not like a way to make higher value quads than this. So is it reasonable for the purples to be capped at 20? Well, we can be 1 plus 8. Sorry, not 1. Our minimum, or is that our max? Let's do our maximum. Our max here isn't actually 9 or 8, because we were saying the oranges would be maxing out at 9 or 8. Do we want max or min? I think we definitely want min. I don't know. How many cells are there? 1, 2, 3, 4, 5, 6, 7. 20 over 7 is 2.8, so we want the minimum. So we want 1 plus 5 plus 1 plus 2 plus 1 plus 5 plus 2 is 17. Okay. So I think that we have 3 degrees of freedom on our purples. Why did I put 5, 8 here? Oh, because of the 6, 7. We don't know that's going to be 6, 7, so I have to be careful. But so let's undo all this. Okay, so three degrees of freedom from the minimum. So that means that's 1, 2, 3, 4. This is 1, 2, 3, 4. This can't be 5 or 6. This can't be 9. And this can't be 5, 6, or 7. And I really hope my logic is good there. Does that, I mean, that limits some of these sums in some ways, but how about our, does that limit our 34 at all? So we can be 5 plus 9 plus 9 plus 9 plus 4 is 36. So we actually only have 2 degrees of freedom down from the 5 now. So this can be 7, 8, 9, 7, 8, 9, 7, 8, 9. Just to make sure, 2 plus 9 plus 9 plus 9 plus 5 is 34, yeah. Okay. What can this 28 be now? 4 plus 9 plus 8 plus 9 plus 8 plus 4 is 42. That's silly. So they have to be small, not large. How about this 13? Because we got rid of 2 degrees of freedom from the bottom here, so that should remove 2, right? 5 plus 1 plus 1 plus 1 plus 3 is 11. So we have 2 degrees of freedom, so this can't be 7 or 8. 2 degrees of freedom, sorry. So this can't be 8, 4, 4, 5, or 4, and that one's fine. So just to make sure, we can do 5 plus 3, sorry, not 3. 5 plus 1 plus 1 plus 1 plus 5 is 13, yeah. So I got rid of degrees of freedom from the 40, is that right? So 8 plus 9 plus 9 plus 9 plus 7 is 42. So I have 2 degrees of freedom down on the 40. So that can't be 5, that can't be 5, 6, that can't be 6, that can't be 5, 6. There goes my dog. What's next? This 15? Because that's 6 here. That's 6 now. So 6 plus 1 plus 1 plus 1 plus 2 is 11. So I have 4 degrees of freedom. So that can't be 6, and that can't be 6 or 7. So we can do 2 plus 1 plus 1 plus 1 plus 6, yeah. This feels like a lot, but not enough at the same time. Does that change our maximum orange? Because we really don't have very many degrees of freedom left on this diagonal here. So I can't have 8 and 9. Can I? So if I had an 8 and a 9 in here, somewhere in here, they'd both affect this, making this a 7. Don't think that has any other effect on the box at the moment. That would do this, right? But either the 8 or the 9 would be here. I guess the 8 would have to be down here, right? So it would have to be a 9 here and then an 8 down here somewhere so that we don't get rid of the 9 here. And that should still work. So we'd be 3, 7, 9, 9, 4. Oh, wait. Oh, did we remove an upper bound from here? Let's take a look. Undo all this so I don't get lost. 5 plus 9 plus 9 plus 9 plus 4 is 36. Yeah, that's still 2 degrees of freedom. So 5 plus 7 plus 9 plus 9 plus 4 is 34, and that's correct. I don't know where my 32 came from before. Oh, I typed 3 instead of 5. So yeah, so I could have a 9 here and an 8 down here. And then I'd have to make sure not to use in this box. Well, I could put an 8 here somewhere, because that would be fine. And then, so this removes 8, 9 here, removes 8 from here, and 8 from here. I have to be careful not to remove the 9. But I can have a 7, for example. That would still work. And then it seems like I could do 5, 6, 7, 8 then. Yeah, because I can't have a 9 in this quad. And then I could do, I can't use 7. So can I do 4, 5, 6, 9? No, oh wait, I can do the 8. That's right. Let me undo that a little bit. So we know there'd be an 8 here, and then I can't use a 7. So can I use 5, 6? So this would be a 4. And this is still at our maximums. So that makes my orange, and then this we said can be 8, 9. Wait, 8, 9 would force a 7 here. Oh. So this orange can't be 8, 9, because if I did that, oops, if this were 8, 9, that sees both of these, making them both 7, and now I've lost all my degrees of freedom. So this orange can now be, so we're going to say this is still 8, 9, 8, 9, like that, because this one can't be 9. So this can't be 8, 9. This could be 7, 9, and that uses all our degrees of freedom. And so then this one can't use 9 or 7, so it would be 6, 8. Which may actually add to the same as what we had before. But anyway, so let's add this up. So starting with the quads, we have 9 plus 5 plus 6 plus 8, plus 5 plus 6 plus 7 plus 8, plus 7 plus 9 plus 6 plus 8, plus 17 twice is 118. I think I just found a better maximum for the oranges, which completely invalidates everything I just did. Let me just add that again to make sure. So I got 17 times 2. That's our corners. I've got 6 and 8. I've got 7 and 9. Then I got 5, 6, 8, 9. I've got 5, 6, 7, 8. 118. I had 113 last time. So I think last time I just didn't properly calculate what orange could be. Let's get back to what we had. That changes what the purples can be, which that whole cycle that I did is invalid because it means that purple is not less than or equal to 20. Purple is less than or equal to 93 minus, oh yeah, it's 118. So orange max is 118. So 118 minus 93. Purple is less than or equal to 25. Right, what was the minimum? 1 plus 5 plus 3 plus 2 plus 1 plus 1 plus 6 is 19. 25 minus 19 is 6. So that was 6 degrees of freedom on the purples. Let's go back to when I did that to the purples. So this is when I added 3 degrees of freedom. So I should have added 6 degrees of freedom. So none of these are actually affected, which means I can't do any of the eliminations that I did before. Which means these could actually be slightly higher. I don't think this is how you're supposed to do it. I don't know how to do it, so I've given this a good hour 15 and I haven't placed a single digit, so I think I'm just going to give up. All right, well, thanks for the suggestion, but I was not able to really make progress in the live solve environment for this. Maybe if I poked at it more on my own, I'd be able to figure it out. But again, I'm not very experienced with little killers in general. I feel like there's something obvious that I'm missing, but I just don't have the experience to pick that out. As you can tell, I really tried though, so I don't know exactly what I missed, but I hope you enjoyed the video. And maybe I'll try one of your other puzzles in the future. Maybe one that's more suited for a live solve for me, where it's a little bit easier. But yeah, thanks.